We're now going to give some definitions for systems of linear equations in 3 variables. So specifically, systems in 3 variables means that we have 3 variables at most, 3 variables only in each equation. Typically, this also means that we'll have 3 equations, but that doesn't necessarily have to be true most of the time. And the method that we're going to use to solve these is something that is called Gaussian elimination. There's a reason we're doing this, because in the next chapter we're going to use Gaussian elimination again, and so we want to introduce it now so that you're better prepared for matrices and simplifying matrices and solving matrices. So Gaussian elimination is the process of eliminating the first variable first. Then eliminate the second variable, and this is typically x. And that's typically the y. Then we solve for the third, which is typically the z. So now we'll have a z equals something. And then we'll solve for the y, solve for the second, and we'll get a y equals something. And then we close by solving for the first. So we get an x equals something. So Gaussian elimination is specifically eliminate x's, then eliminate y's, then solve z, solve y, solve x. Now, just like our general systems of equations, there are 4 different words you need to know about the types of solution. Consistent says, again, same as before, it has an answer, at least one. It could have multiple. Inconsistent says it has no answer. Independent says all variables are independent. Or another way of saying that is that no variable depends on any other. Whereas dependent, they do. At least one variable is tied to another, is dependent on another. So if the second one changes, then the first one will change as well. 2 more definitions. Non-square is what we say when we have something that doesn't have it. So non-square and square, let's add this in. Let me actually start with square. There are as many equations as variables. If there are as many equations as there are variables, then it's square. And this just means that there aren't as many. There are typically fewer equations than variables, but it could be or more equations than variables. As long as it doesn't line up perfectly, 3 equations, 3 variables, 2 equations, 2 variables, then it's not square. If it does, 3 equations and 3 variables, 2 equations and 2 variables, then it is square. And parametric is just a way of writing dependent answers. And the idea here is that we'll have x equals some value, something times z plus something, and y equals something times z plus something, and z is just z, or we could use a t here. And y is some value of t plus something, and z is just t. And if this is the case, then it's parametric, so that the x, the y, and the z can all be found by picking some t. And we'll show you what that means later as we work through these problems.